In the third part of the lecture, we will talk on the transducers, like loudspeakers and microphones, and after that, headphones and earphones. I will start with loudspeakers and microphones. We can characterize loudspeakers depending on their transducer technologies. For example, like electrodynamic, electrostatic, magnetostatic, magnetostrictive, piezoelectric, ribbon or planar magnetic loudspeakers or bending wave loudspeakers. It is also valid for microphones. There are huge amount of transducer principles which are suitable for microphones. For example, electrodynamic microphones, electromagnetic microphones, condenser or electrostatic microphones, piezoelectric and ferroelectric microphones, micro-electromechanical system microphones, fiber optic microphones, or laser microphones. Of course, in this lecture, we cannot talk all of these loudspeakers and microphones. Therefore, I have selected two different loudspeaker technologies and one microphone technology, because in most cases we apply, for example, electrodynamic loudspeakers or electrostatic loudspeakers, and also in most measurements we use condenser electrostatic microphones. Therefore, I will start first of all with electrodynamic loudspeakers. Actually, electrodynamic loudspeakers are most common loudspeaker type. This type of loudspeakers are based on the interaction between magnetic fields. And we have a static field and at the same time a dynamic field surrounding a moving conductor voice coil. Actually, the cone moves air back and forth for the sound propagation. And we would like to have, in that case, light and stiff diaphragm, which we also say cone, for this aim. And most of the cases, the material of the cone is paper pulp or plastic. In this picture, we see also dust cap. It protects the system from the metallic dust. It is also important. And of course, because of the movement, the cone should be also supported by surround and in the below part of the loudspeaker using spider. And in that case, if we apply any audio signal to the voice coil, it generates a force and therefore cone starts to move. In that case, if we apply an audio signal to the voice coil, it carries an electric current and the magnet and voice coil generates a force on the voice coil. And we can describe this force for a current I. The force will depend on the magnetic field strength B and the coil length L. And at the same time, of course, moving the wire or rod within the stationary field induces an electric voltage, and we can describe this electrical voltage again using the magnetic field strength and the coil length, and directly related to the velocity. These are important to describe our electromechanic acoustical system, electrodynamic loudspeakers in electrical case. Of course, our loudspeaker has also mechanical parts, and we should also describe these mechanical parts. We have a motor force which applied in this case, and some force is needed to accelerate the mass and to compress the spring of the system. And therefore, of course, we have at the end the force F, which will be used for the sound generation. At the other side, of course, acoustical part of the electrodynamic loudspeaker is quite important. And as an ideal model, if we take into account a piston, which you see in this picture, and we without a mass in ideal case. And if we apply a force, of course, there are a relationship between the force and pressure, and at the same time, there is a relationship between the velocity and volume velocity. They are all dependent regarding area. Of course, at the end, if we develop a network model for this electrodynamic loudspeaker, we should take each these steps into account. And we see that in the first step, of course, regarding our amplifier, we should take into account a resistance. At the same time, our voice coil has a resistance and inductance. It should be also taken into account. And after that, of course, we should think about the transformer. We have a force factor, the relationship between the voltage and the velocity, and at the same time, the relationship between the current and the force. And after that, of course, starts the mechanical aspects. At the end, this force will be applied to the voice coil, and the cone will move. And of course, the mass of this cone, at the same time, mass of the voice coil, or also spider and surround, should be taken into account. At the same time, we have, of course, a damping in the system. We should also think about it. And also, spring properties of the surround and the spider are quite important, and we should also model them. After that, we have next transformer, because for the acoustic radiation. In that case, of course, we have a transformation between the velocity and volume velocity, and between the force and the pressure. At the end, of course, sound field or air also has a mass and also resistance, and this mass and resistance should also be taken into account. We have already discussed in the lecture about the theoretical background of electrodynamical loudspeakers and also network modeling. And I would like to make a measurement with you now. Therefore, we have built this setup, triangulation sensor, to measure the amplitude and at the same time electrical parameters. And we have selected a new loudspeaker for this aim, and you can build this loudspeaker also at home. To build these loudspeakers, you need only 2 beer casters and at the same time 1 business card, 7.5 meter enameled copper wire, double-sided tape, 1 voice coil former, and 1 super magnet. We built now this loudspeaker on our now integrated to the measurement system, and we would like to make a measurement. Therefore, we will play some electrical signal, we will use an amplifier and make some measurements. Therefore, we need some reflection, and therefore we used a correction fluid, and laser signal will be reflected. In this measurement, we get information about electrical parameters, but at the same time for mechanical parameters. And then in detail we can see, for example, resistance, inductance and other information, but at the same time information about mass, damping or stiffness. And taking into account this information, of course, we can evaluate the loudspeaker. At the same time, in this picture, we see the magnitude of electric impedance, and we see at which frequency this impedance has a peak. And again, we can compare the signal-noise ratio using this picture. In this picture, we see the measurement signal and at the same time, the noise flow. Most important step after the measurement is the perceptual evaluation. And we will hear now music signal to evaluate this loudspeaker.